What if everything you've been told about success is only half the story? Behind every legend is a journey no one talks about. The failures, the sacrifices, the moments that almost broke them. From innovators to world changers to minds that shaped history, we break down what truly made them great. Because greatness isn't luck. This is Greatness Explained TV, where greatness is broken down. Subscribe and start thinking like the greats.
It was past 1 in the morning. The hospital ward was quiet. A single nurse sat at her station just outside the room, the overhead lights dimmed to a pale yellow hush. Inside, an old man lay in the stillness, his white hair splayed against the pillow, his chest rising and falling slowly. On the nightstand, a stack of papers, 12 pages of handwritten equations, cross-outs and corrections crawling over every inch of the margins, right down to the final line. He had been writing until the pain became too great, until the pencil could no longer move. Beside those equations lay the unfinished draft of a speech he would never deliver. In the small hours of April 18, 1955, the nurse heard him call out, a few words in German, sharp and sudden, cutting through the silence. Then nothing. The aneurysm that had been quietly swelling for years finally gave way. And Albert Einstein, the man who had spent 76 years trying to read the handwriting of God, was gone. No fanfare, no audience, no equation on the board. Just a man, a bed, and 12 pages of unfinished mathematics. What do you do with a life like that? We live in a world shaped by his ideas every single day. The GPS that guides your car to your destination would be useless without his theory of relativity. The lasers in your phone's face recognition system trace their lineage directly to his quantum work. The nuclear energy powering cities, the cosmological maps astronomers use to chart the edge of the observable universe, all of it, carries the fingerprints of one human mind that burned itself out searching for a final, beautiful, unified answer. But here is what I want you to sit with before we go any further. Albert Einstein was not born a genius. He was not handed a gift and told to deliver it to the world. He was, at various points in his life, a school dropout, a failed job applicant, a rejected academic, a husband who lost his first child to secrecy, a man whose country tried to erase him, and a physicist whose greatest colleagues eventually thought he had lost his way. And yet, by the time that nurse heard his final words in the dark, he had personally ruptured 2 centuries of scientific certainty, remapped the cosmos, predicted the existence of black holes, gravitational waves, and quantum entanglement, most of which would only be confirmed decades after his death. So stay with me, because this story is not really about physics. It is about what happens when a human being refuses to let the world tell them what is possible. And somewhere in these 76 years, there is something waiting for you. A question, a challenge, a mirror held up to your own life. Subscribe to this channel if you haven't already. We go deep into the lives of the men and women who changed history, and we ask what their lives are still saying to us today. Let us go back. Let us go all the way back to Ulm, Germany. The year is 1879. Before Einstein changed the world itself was a very different kind of place. Physics in the late 19th century was a cathedral, grand and complete. Isaac Newton had laid the foundations 200 years earlier, laws of motion, universal gravity, a clockwork universe where causes produced effects with mathematical precision, and every particle in existence moved according to rules as fixed as iron. By 1879, scientists were polishing the marble. Lord Kelvin, one of the most decorated physicists in Britain, would soon stand before an audience and declare with breathtaking confidence that there was nothing new left to discover in physics. All that remained was more precise measurement. This was the world into which Albert Einstein was born, a world that believed it had already answered the deepest questions. A city in the kingdom of Württemberg in southern Germany wore as its motto a phrase that would prove quietly prophetic: Ulmenses sunt mathematici. The people of Ulm are mathematicians. It was here, in a modest apartment, that Hermann and Pauline Einstein welcomed their first child on the morning of March 14, 1879. They had considered naming him Abraham after his grandfather. But the name sounded, as they put it, too Jewish. And so they kept the initial letter and called him Albert. The Einstein family was Jewish, secular, assimilated, deeply comfortable in German culture. Hermann Einstein was a gentle, hopeful man with an inclination for mathematics but a persistent inability to make money. He was the kind of man who believed in the next venture, the next opportunity, the next partnership. His wife Pauline was sharper, practical, witty, her laughter capable of being both infectious and cutting. It was from his mother that Albert would inherit his acid wit and his piano, the two things he would carry through every storm of his life. Within a year of Albert's birth, Hermann's business foundered, and the family relocated to Munich, drawn by the ambitions of Uncle Jacob, an engineer who had launched an electrical supply company. The Einsteins settled into a comfortable house with a large garden, and for a season they knew prosperity. In 1882, the company provided the electrical lights for Munich's first Oktoberfest. In 1885, they had 200 employees. The future looked bright. But Munich was also a place of shadows. Anti-Semitism was woven into the fabric of ordinary life. Albert, enrolled at the local Catholic school, there was no Jewish school nearby, did well enough in religious instruction to help his classmates with their homework. But on the walk to and from school, he was taunted and shoved for being Jewish. He learned early what it meant to be an outsider. He learned it not from books but from the gravel of Munich streets. And here is something important. He did not try to disappear. He did not try to blend in. Albert Einstein, from a very young age, made peace with being apart. He retreated not into bitterness but into his own interior world. He was the boy who built card towers 14 stories high. The boy who played alone while the other children poured into the street to march behind the soldiers. And when those soldiers came and children ran to join the parade, Albert would stand and watch. And cry. "When I grow up," he told his parents, "I don't want to be one of those poor people." He had already decided, before he understood the word, that he would not be shaped by the crowd. And then came the compass. He was 4, perhaps 5 years old. He had fallen sick and his father brought him a simple toy, a magnetic compass. He held it in his hands and watched the needle tremble. It moved as though something invisible were pulling at it, something beyond the reach of his fingers. Something hiding in the empty air. He trembled. He grew cold. He never forgot it. Decades later, writing in old age, he would describe the experience with the vivid urgency of a fresh wound. Something deeply hidden had to be behind things. That was the spark. That trembling needle was the beginning of everything. At 9, he moved to the Luitpold Gymnasium, a school of some intellectual reputation. He was a good student. Contrary to the myth that would later attach itself to his name, he never failed mathematics. By 15 he had taught himself differential and integral calculus. At 12, he received an elementary geometry textbook as a gift and he called it, for the rest of his life, his sacred little geometry book, reading it with the wonder of a man who had glimpsed something holy. But the school itself he despised. The mechanical drilling, the rote learning, the worship of authority, it made his skin crawl. His teachers did not know what to make of him. One sent him away because his mere presence, the quiet, skeptical smile in the back row, disturbed the order of the class. He learned something from this that would follow him into every laboratory and lecture hall he ever entered. A foolish faith in authority, he would write at 19, is the worst enemy of truth. When he was 12, a medical student named Max Talmud began dining weekly with the Einstein family, an old Jewish custom, hosting a poor scholar for the Sabbath meal. Talmud brought books. Popular science books by Aaron Bernstein, volumes that described experiments, that celebrated the joyful wonder of discovery, and that returned again and again to a single tantalizing subject, the speed of light. What would it mean, Bernstein asked, to ride alongside a beam of light? What would you see? Albert Einstein read those books with, in his own words, breathless attention. He was 12 years old. The question burrowed into him and refused to leave. He would carry it for 10 years before he found the answer. And then, when he was 15, the world caved in. Hermann Einstein's company collapsed. The contracts they had counted on went to larger firms with stronger connections. The family left Munich in disgrace, moving to Italy to try again. And Albert was left behind in a Munich boarding house to finish his schooling alone. He lasted a few months. Then he walked out. He presented a doctor's certificate claiming nervous exhaustion and left the gymnasium without a diploma. He crossed the Alps on foot and arrived in Milan, unannounced, on his parents' doorstep. He was 16 years old, stateless, his German citizenship formally renounced. He had applied to shed it before leaving, determined to be bound to no nation. His father was dismayed. What was the plan? What was the future? He would become a physics teacher, Albert said. He would take the entrance exam for the Swiss Federal Polytechnic in Zurich. He failed it. He was 2 years younger than the other candidates, brilliant in mathematics and physics but woefully underprepared in French and botany. The director of the school, to his credit, recognized something unusual in the boy and suggested he spend a year finishing his secondary education in the small Swiss town of Aarau. That year in Aarau was the one genuinely happy year of Albert Einstein's adolescence. The school was progressive, the teachers curious, the environment warm. He boarded with a family named Winteller and fell in love with their daughter. He played Mozart with abandon. He learned what it felt like to be valued for the way his mind worked, rather than despite it. And in Aarau, he asked himself the question that would rewrite physics. He was 16. He imagined riding alongside a beam of light. If he could travel at the speed of light and look at another beam of light beside him, what would he see? Would the light appear to stand still? Maxwell's equations said that electromagnetic waves moved at a fixed speed. But if you matched that speed, then by the logic of Newtonian mechanics, the wave would appear frozen. A stationary oscillating field, which was, Einstein sensed in his bones, impossible. The question lodged itself in him like a splinter. He would not extract it for 9 more years. He retook the entrance exam for the Polytechnic in 1896 and passed. He arrived in Zurich with a freedom he had never known. No family watching, no authority to chafe against, no marching soldiers. He threw himself into physics and mathematics, attending the lectures he found essential and skipping the ones he found pedestrian. He borrowed the notes of his friend Marcel Grossman when he missed too much and scraped through his exams. He loved the coffee houses and the late nights. He loved the philosophical debates, the violin he carried everywhere, the way a good problem could fill an entire afternoon. He fell in love with Miliva Maric, a Serbian physics student, the only woman in their cohort, brilliant and serious, someone who matched him intellectually and could tolerate his consuming absences into thought. But graduation brought no salvation. He applied for academic assistant positions and was rejected at every turn. His professors, whom he had not exactly flattered with his attendance record, declined to recommend him. He applied to jobs in schools, in insurance offices. Rejection after rejection. 2 years of nothing. In 1902, desperate, he finally secured a position at the Swiss Patent Office in Bern through Marcel Grossman's father, who knew the director. Third-class technical examiner. The work was to evaluate patent applications, to determine whether the ideas submitted were new and workable. And Albert Einstein, the man who would become the most celebrated scientist in human history, sat at his government desk, reviewed his patents, and in the hours between applications, in the margins of his notebooks, quietly dismantled the foundations of classical physics. He was not supposed to be there. He had not been chosen. The academy had not opened its doors. So he built his own. He and a small circle of friends, Conrad Habicht, Maurice Solovine, formed what they called with affectionate mockery the Olympia Academy. They met in each other's apartments and ate simple food, sausage and cheese and tea, and read Hume and Mach and Spinoza and Poincare. They argued until midnight and then climbed mountains to watch the sunrise. They laughed constantly. They were poor and unknown and completely, serenely alive. It was in this exile, this bureaucratic purgatory, that Einstein's greatest work was born. The year 1905 is called his Annus Mirabilis, his year of miracles. He was 26 years old. He was a patent clerk with no laboratory, no university, no research grant, and no supervisor. And in a 4-month frenzy from March to June, he submitted 4 papers to the Annalen der Physik that permanently altered the course of human knowledge. The first paper explained the photoelectric effect, the phenomenon by which light striking a metal surface releases electrons, by proposing that light itself was made not of continuous waves but of discrete packets of energy. Quanta. He called them light quanta. The world would later call them photons. This was the paper that, 18 years later, would win him the Nobel Prize. It was, he admitted to Habeck in a letter, very revolutionary. The second paper provided mathematical proof for the existence of atoms by explaining Brownian motion, the random jittering of microscopic particles suspended in liquid as the result of being bombarded by invisible molecules. The third paper, the one the world would most remember, was titled, deceptively modestly, On the Electrodynamics of Moving Bodies. It was the special theory of relativity. It resolved, at last, the 10-year splinter in his mind. There is no absolute time. There is no absolute space. The laws of physics are the same for all observers moving at constant velocity. And the speed of light is constant for every observer, regardless of their motion. The implications shattered 2 centuries of Newtonian certainty. Time was not a fixed river flowing at the same rate for everyone. It slowed depending on how fast you moved. Distances contracted. Events that one observer saw as simultaneous, another observer moving differently through space might see as separate. The universe was not the comfortable, predictable machine Lord Kelvin had declared complete. It was something stranger, more flexible, more astonishing than anyone had dreamed. A few months later, Einstein added an appendix, a short, 3-page paper whose famous conclusion has become the most recognized equation in human history. Equals mc squared. Energy and mass are not separate things. They are interchangeable. The energy locked inside a piece of matter is its mass multiplied by the speed of light squared, a number so immense that even a tiny fragment of mass contains energy beyond imagination. He submitted these papers from a government desk in Bern, Switzerland, between reviewing patent applications. He had no telephone. He had no collaborators. He had Mileva, who checked his mathematics, and the Olympia Academy, who had sharpened his philosophical tools. And he had, above all, an absolute refusal to accept that the universe had to behave the way everyone else assumed it did. The physics community responded with something between confusion and grudging admiration. A few senior physicists, Max Planck chief among them, recognized immediately that something seismic had happened. Others ignored him. Some dismissed him. And Einstein went back to his desk and kept thinking. He had solved special relativity, the physics of objects moving at constant velocity. But gravity was still the old Newtonian gravity, a force that acted instantly across any distance, violating his new conviction that nothing could travel faster than light. There was a contradiction at the heart of things, and he could not leave it alone. In 1907, while writing a review article on relativity, he paused. He let his mind drift. He imagined what it would feel like to fall freely, to step off a building and plummet. In free fall, he realized you would feel no weight at all. The gravitational field would vanish from your immediate experience. And the opposite. If you were in a sealed box, accelerating upward in empty space, you could not distinguish that from standing still in a gravitational field. Gravity and acceleration were equivalent. They were the same thing wearing different names. He later called this the happiest thought of his life. From that thought experiment, over the next 8 years, through a failed marriage, through the outbreak of World War I, through intellectual battles with rivals and his own failed equations, Einstein would construct the general theory of relativity. It described gravity not as a force but as the curvature of spacetime. Mass warped the fabric of space and time around it, and other objects moved along those curves. The planets did not orbit the sun because the sun yanked them with invisible chains. They followed the gentle curves the sun's mass had carved into the geometry of space itself. When a blind beetle crawls over the surface of a curved branch, he explained to his young son Edward, it doesn't notice that the track it has covered is indeed curved. I was lucky enough to notice what the beetle didn't notice. He completed the field equations of general relativity in November 1915, after years of wrong turns and discarded notebooks. When he finally arrived at the correct formulation and calculated that it precisely accounted for the anomalous precession of Mercury's orbit, a small but stubborn discrepancy that Newtonian gravity could not explain, He was so overcome that his heart pounded and he could not sleep for 3 days. He had rewritten the universe. And he knew it. But the world did not know it yet. That would require a different kind of moment. Now I want to pause here, because before we arrive at the moment of triumph, we must descend into the years that nearly destroyed him. Because this story, like every real story, passes through its darkest valley before it reaches the light. The years between 1914 and 1919 were the years in which Einstein was most completely human, most thoroughly broken. He was working in Berlin, increasingly isolated, watching Europe tear itself apart in a war he found morally incomprehensible and militaristically obscene. Every time soldiers marched by, every time the newspapers celebrated another offensive, he grew colder and more remote. He signed an anti-war manifesto. He was one of 4 signatories in all of Germany willing to put their name to peace. Meanwhile, his marriage to Mileva, always fragile, always a vessel of compromises and resentments, had finally shattered. She returned to Zurich with their 2 sons, Hans Albert and Eduard, and Einstein was left in Berlin, working alone, eating badly, barely sleeping. At one point he collapsed from exhaustion and stomach ailments and was bedridden for months. He lost 50 pounds. His cousin Elsa nursed him back, and they began a relationship that would eventually become his second marriage. He tried to maintain contact with his sons by letter. He wrote to Hans Albert with a tenderness that never fully found its way into the rooms they shared. He worried about Eduard, who was beginning to show signs of the psychological fragility that would one day, in a terrible parallel to Isaac Newton's isolation, tip into full mental illness. And through all of this, through the divorce proceedings, the illness, the war, the estrangement from his children, he kept working. He rewrote his gravitational field equations night after night. He played violin in his kitchen until the answer came. Of course, like all great beauty, he said of Mozart's music, his music was pure simplicity. And that was what he was looking for in physics too. The beautiful, simple thing underneath the complexity. He never stopped looking. Then came 1919. The war had ended. Europe was still bleeding. And a British astronomer named Arthur Eddington sailed to the island of Principe off the coast of West Africa to photograph a total solar eclipse. Einstein's general theory of relativity predicted that the sun's gravity would bend the path of starlight passing near it. The amount of bending was precise, calculable, testable. During a total eclipse, the sun's disk was blotted out, and stars near the edge of the sun became visible. Eddington photographed them. He compared their positions to their known positions when the sun was elsewhere in the sky. The stars had shifted, exactly as Einstein predicted. On November 6, 1919, at a joint meeting of the Royal Society and the Royal Astronomical Society in London, the astronomer Royal J.J. Thomson stood and announced the results. This is the most important result obtained in connection with the theory of gravitation since Newton's day. The next day, the Times of London ran the headline, "Revolution in Science, New Theory of the Universe, Newtonian Ideas Overthrown." Within 48 hours, Albert Einstein was the most famous human being on Earth. It was sudden and overwhelming and, in many ways, absurd. He had submitted his papers, worked in relative anonymity, been a patent clerk, lived in a Berlin apartment, lost 50 pounds in his sickbed. And now strangers gathered outside his window. Lecture halls overflowed. Newspapers in Japan and Argentina and South Africa printed his photograph. He was offered movie roles. Shops sold toys and portraits bearing his likeness. A man with wild hair and a faraway look had become the symbol of human intelligence itself. He received it with a mixture of genuine amusement and profound discomfort. "To punish me for my contempt of authority," he later said with dry self-awareness, "fate has made me an authority myself." He was celebrated in America, toured Japan, visited Palestine, spoke to crowds of thousands. He was given the Nobel Prize in 1921, not for relativity, which the committee still found too controversial, but for the photoelectric effect, the first of his 1905 papers. He received the telegram while traveling by ship and continued sailing. And through all of it, the dark current continued to run beneath the surface. In Germany, the Nazis were rising. They were not yet in power, but their presence was sharpening, their anti-Semitism becoming more public and more violent. Einstein had become, for them, a symbol of what they called Jewish physics, abstract, rootless, cosmopolitan. Physicists like Philip Leonard, a Nobel laureate himself and a venomous anti-Semite, publicly attacked Einstein's work as degenerate. In August 1920, a rally in Berlin's largest concert hall was organized specifically to denounce relativity as a Jewish conspiracy. Einstein attended. He sat in a box, crossed his legs, smiled, and applauded the speakers sarcastically. But the threat was no longer merely rhetorical. By 1932, the Nazis had become the largest party in the Reichstag. Einstein was in Pasadena, California, when he understood, not gradually, but suddenly, with the clarity of a thought experiment, that if he returned to Germany, he would not be safe. He had enemies with uniforms and weapons. His summer house had already been confiscated. His bank account had been raided. He boarded a ship and sailed away. He never returned to Germany. He accepted a position at the newly founded Institute for Advanced Study in Princeton, New Jersey. In December 1932, he crossed the German border for the last time. "Take a very good look at it," he told his wife Elsa. "You will never see it again." He was right. A few months later, Hitler was appointed chancellor. Within weeks, Einstein's German citizenship was revoked. His property was seized. The Gestapo raided his Berlin apartment looking for weapons caches they never found. His name was added to a list, alongside that of a German artist whose work was deemed sufficiently dangerous to require assassination. The bounty on Albert Einstein's head was 50,000 Reichsmarks. A Nazi publication described the reward and added, beneath a photograph of his face, the caption, "Not yet hanged." He arrived in Princeton and never left. For the remaining 22 years of his life, Einstein walked the same path, from his house at 112 Mercer Street, through the quiet New Jersey streets, to his office at the Institute, every morning. He wore old wool pullovers and no socks. He sailed his little boat on Carnegie Lake. He played violin badly and piano worse and loved both without apology. He was gentle with his assistants and fierce in his commitments. But he was also, in those final decades, a man who had moved to the outer edge of his field. The physics world had not stood still. A new generation had taken the quantum revolution that Einstein himself had helped ignite and built from it something that disturbed him deeply: quantum mechanics. The Copenhagen interpretation, led by Niels Bohr, held that at the subatomic level, reality itself was fundamentally probabilistic. Particles did not have definite positions or velocities until they were observed. God, in the language of the young physicists, played dice. Einstein did not accept this. He could not. It violated everything he believed about the nature of reality, his conviction, rooted deep as a child's wonder over a compass needle, that there was something real, something definite, something lawful underlying the apparent randomness. God does not play dice, he said, over and over, in letters and lectures and conversations and debates. Bohr, his great interlocutor, his rival and friend, would reply with what became the most famous rejoinder in the history of science: Einstein, stop telling God what to do. He spent the last 30 years of his life chasing a unified field theory, a single mathematical framework that would reconcile general relativity with quantum mechanics, that would explain all the forces of nature in one beautiful, coherent structure. He never found it. His collaborators, year after year, watched him fill blackboards with equations and then erase them. Watched him begin again. Watched him say, when a promising approach finally failed, "Well, we've learned something." The physics world largely concluded he had lost his way. The young Turks of quantum mechanics saw him as a revolutionary turned conservative, a man whose very greatness had trapped him in the past. There were headlines about his quest: "New Einstein theory gives a master key to the universe," and then retraction, and then silence. He knew what they said. "I must seem like an ostrich," he wrote to a colleague, "who buries his head in the relativistic sand in order not to face the evil quanta." He did not stop. And then, in 1939, a Hungarian physicist named Leo Szilard came to visit him at his summer house on Long Island. Szilard was frightened. He had been working on nuclear chain reactions. The possibility that splitting an atom of uranium could release enough energy to trigger further splitting, in a cascade of almost incomprehensible power. He and a colleague were terrified that Germany was already pursuing this. They needed to warn the Belgians not to sell uranium from the Congo to the Nazis. And the person who could most effectively reach the Belgian royal family was Albert Einstein, who happened to be personal friends with the Queen Mother. Einstein had not followed nuclear physics closely. When Szilard explained what was possible, Einstein paused and then said quietly, "I had never thought of that." He wrote the letter. After several drafts, it was addressed to President Franklin D. Roosevelt. It explained what atomic fission was. It explained that it might be possible to construct bombs of extraordinary destructive power. It urged the United States to take the possibility seriously. Roosevelt read it. He established what would eventually become the Manhattan Project. And in August 1945, 2 atomic bombs fell on the cities of Hiroshima and Nagasaki, killing over 200,000 people. Einstein was at his summer house when he heard the news on the radio. He said only, "Oy vey." And then he went silent. He had not worked on the bomb. He had been denied security clearance. He was not part of the Manhattan Project. But his equation, his 3-page appendix from 1905, equals mc squared, was the theoretical foundation on which everything depended. And his letter had opened the door. For the rest of his life, he carried the weight of that knowledge. He threw himself into the movement for nuclear disarmament, for a world government, for international controls on weapons. He warned of annihilation. He signed manifestos. He spoke to anyone who would listen. Each step appears as the inevitable consequence of the one that went before, he said on television in 1950. And at the end, looming ever clearer, lies general annihilation. On April 11, 1955, 1 week before he died, he signed what would become known as the Russell-Einstein Manifesto, a joint declaration with the philosopher Bertrand Russell, calling on the governments of the world to resolve their disputes peacefully. It was one of the last things he did. And then, on the evening of April 12, he felt a pain in his side. He came home. He lay down. Helen Dukas heard him rush to the bathroom in the night and collapse. His aneurysm had begun to tear. The doctors told him that surgery might, perhaps, extend his life. He refused. "It is tasteless to prolong life artificially," he said. "I have done my share. It is time to go. I will do it elegantly." In the hospital, in his final days, he asked for his glasses and his pencils. He jotted equations. He spoke to his son Hans Albert about science. He worked until the pain made it impossible. And then, sometime after 1 in the morning on April 18, 1955, the aneurysm burst, and Albert Einstein left the universe he had spent his life trying to understand. Now hear me on this. The GPS on your phone right now, the one guiding you through traffic or telling your delivery driver where to bring your food, it would be wrong by about 11 kilometers every single day if it did not correct for the predictions of general relativity. The satellites that run GPS systems move at high speeds and sit in weaker gravitational fields than we do here on the surface. Einstein's equations predict that time runs slightly faster for them than for us. The GPS software corrects for this, every second, invisibly. Without that correction, the system would drift and fail within hours. The lasers in your hospital scanner, in the devices that read your retina, in the CD players that preceded your streaming services, in the printers and the surgical tools and the fiber optic cables carrying data across the ocean, all of them descend from the theory of stimulated emission that Einstein described in 1917. LASER is an acronym, light amplification by stimulated emission of radiation. His discovery. His name attached permanently to the light that reads the world. The cosmologists mapping the birth and expansion of the universe. The team that in 2016 announced that they had detected gravitational waves, ripples in the fabric of space-time first predicted by Einstein's equations a century before. They were confirming, at last, something he had worked out in 1915 while his marriage was collapsing and Europe was going to war. Every MRI machine. Every nuclear power station, every understanding we have of stars, of black holes, of the first seconds of time itself, all of it runs through the mind of a boy who trembled before a compass needle and asked, in all seriousness, what it meant. His ideas outlived him. They outgrew him. They are still growing. And now I want to turn this story toward you. Because this is the part that matters most. Albert Einstein was told, in some form or another, throughout much of his life, that he was not quite what was needed. He left school without finishing. He graduated without distinction. He was rejected from every academic job he applied for. He spent 7 years as a patent examiner while his colleagues built careers. He was dismissed at various points as a failed student, a mediocre physicist, a political agitator, and in his final decades, a man who had sadly lost touch with the frontier of his own field. And yet not one of those verdicts defined him. Because he never let the world determine what was possible. He trusted the compass needle trembling in his hands. He trusted the question he could not let go of, the imagined ride alongside a beam of light, when no institution, no authority, no credential validated that question. He worked in exile in a patent office, in apartments and boarding houses and a summer cottage on Long Island, with a violin and a few friends and an absolute, stubborn, almost unreasonable refusal to stop. What is the question you cannot let go of? What is the compass needle you have been holding, trembling, in private? The idea or the calling or the dream that no one has yet given you permission to pursue? Einstein never waited for permission. He was, as he said himself, a man with a powerful purity, both childlike and profoundly stubborn. He kept the wonder of a child and the endurance of someone who knew that the universe does not give up its secrets easily, and that the search itself, even the search that does not end in triumph, is worthy of a life. He did not find his unified field theory. He died with his equations unfinished. And somehow that, too, is part of the lesson. Because the final thing he wrote, in the small hours before his death, was one more line of symbols, one more attempt to get a little closer to the truth. Not because he expected to succeed. Because that was who he was. The question I leave with you is this. What would you keep working on, even knowing you might not finish? What would you pursue, not for the prize or the recognition or the permission of the world, but because something deeply hidden has to be behind things, and you cannot rest until you have come a little closer to finding out what it is? Close this video and sit with that. And if something in this story moved you, if this life spoke to something in yours, then like this video, share it with someone who needs to hear it today, and subscribe to this channel so you don't miss the next story we tell. Drop a comment below and tell us where you're watching from, whether you're in Lagos or London, in Nairobi or New York, in Sydney or Sao Paulo, we want to know. This channel exists because of you, and every story we tell in the hope that it finds the person who needed it most. Until next time.